No matter how much you spend on a measuring device, there's always going to be error associated in using it. It's important for you to realize that there's no such thing as an exact measurement. There will always be some amount of random error associated in every measurement. Scientists communicate to each other where their instrument begins to become imprecise by using something called significant figures. The last significant figure that a scientist records is always going to be in doubt. That means their measuring device didn't let them know this precisely. So when they wrote that last digit down, it was a complete guess. There's a few rules. All non-zero numbers are significant. Zeros are sometimes significant. It depends on what kind of zero it is. If it's a leading zero, for example, 0.0007, those are leading zeros. They're never significant. There's things called captive zeros. For example, in the number 7.07, this zero is captive. Captive zeros are always significant. And then finally, there's these things called trailing zeros. These are zeros that come after a non-zero number. They're never significant until a decimal place. The minute you see a decimal, that makes all zeros that come after the non-zero number significant. So this number has 4 sig figs. This number, however, has 1 sig fig. So all non-zero numbers are always significant, and zeros are sometimes significant. It depends on what they are. This can lead to some pretty crazy math because of the rules that scientists need to apply whenever they do a calculation involving a significant figure. The rules for doing calculations, when you do addition or subtraction, you want to be careful that you preserve the place of doubt. When you do multiplication or division, then you simply use the fewest number of significant figures. So, you can get some pretty wild calculations. For example, I'm sure most of us learned in school that 7 times 8 is 56. But not if you're going to pay attention to significant figures. 7 times 8, because when I do multiplication, I have to use the fewest number of significant figures. I've got 1 significant figure here, 1 significant figure here. I can't have 2 significant figures in my answer. It should be 60, no decimal. How about one with some addition and subtraction? 9 plus 7.000 divided by 4.00. Well, I've got to do my addition first, and I have to, when I do addition and subtraction, I have to preserve the place of doubt. The place of doubt is right here in the tenths, so I've got 16.0 divided by 4.00. This is going to be 4.00 for the answer.